Hello geometry students, it is Monday, April 27th. I hope you're having a good day and I hope you had a good weekend and enjoyed the sunshine again outside. We had a great birthday feast yesterday for one of my children. We eat like kings around here. I don't know if that's happening at your house, but we're doing an awful lot of eating. We need more exercise, for sure. We're working on that too, but anyway, back to the work at hand. We're going to do one lesson today, lesson 12.3, and we're going to get started. So let's say a prayer. Father in heaven, I just thank you so much for this day. I pray for all of my students that you would help them so much to focus and to learn well from the video, that they would master this material and do great on their Chapter 12 test. And I pray you strengthen me and help me right now to be the very best teacher I can be. Thank you, Lord, that even with math, if we serve you, it will last forever. In Jesus' name, amen. Okay, well, I was looking back at my last email that I sent you with the last lesson, and I referenced a Math 8 video, but I don't think I included the URL for that. So in this email, I will give you the link to the one for 12.2 from Math 8 and also the one from 12.3. You only have to watch a few minutes of it, and I will attach the worksheets that go with it so that you can actually make the 3D figures. It really helps conceptually to understand what you're looking for in terms of surface area, all the different parts, the base and all the sides and everything, and where they get the formulas if you actually make those shapes, or at least cut them out and look at them. So please print those and watch the Math 8 videos, and because they do some easier concepts with surface area to prepare them to come to geometry. And of course we do harder things like hexagonal pyramids and hexagonal prisms and pentagonal things with 5 sides, 6 sides, and using all of that. So anyway, let's get started and I will sit down. All right, so this is lesson 12.3. And we are doing the surface area of pyramids and cones. So let's look at number 1. We're going to draw a picture of a regular square pyramid. So here's the picture. And we have the back side as well, like this. And in the problem, they tell us that the base is 16 centimeters here. And the height comes down inside. I don't know if you can really see that very well. Inside, the height there of the shape is 15. And they also have, well, I'm going to draw that. Hang on a minute, because that cuts across. So hang on a second. Let's put this over here. So this is 15 on this side because we need to draw the height on the outside. So there's the height inside the shape as well as the height in the triangle that's on the outside. And that height is, do they give us that? They do not. Okay, that's part of what we have to figure out. All right, so like we did with prisms, we want to come up with a plan. So you want to have an overall plan. Sorry, my picture's kind of getting ruined here with all these erasures. So we want to have a plan to find the surface area. Okay, so if I look at your shape, if you have one, you can look at it in your hand. You're going to have one square base, and you're going to have 4 triangles that all go around the outside. Okay, so I'm told in the problem that it's a square-based pyramid. So that's our hint. So that if this is 16, then this edge must be 16 also. And when I'm trying to find the area of the base, I just multiply 16 times 16. Okay, now I need each triangle. So here's the triangle, and I have the base is 16 and I don't have the height. Now I want to use a different color and show you what you can see inside and why that's important. So I have 15 here. That represents this interior height there. And then I have a triangle right here that is from the inside and touches the outside. So if I wanted to find my height here on the outside, I can use the Pythagorean theorem. Do you see that triangle inside? It's a right triangle. Now, if this is a square base and the top of my pyramid is directly above the middle of the square, when it comes down, it will cut halfway across. It doesn't really look from the picture, but it does. And that makes complete sense because in order for it to be a square base pyramid, the top has to be directly over the middle. All right, so I want to find my height there, and that's going to be using the Pythagorean theorem. So I have 15 squared plus 8 squared equals h squared. And 15 squared is 225, and 8 squared is 64. And I add those together, and I get 289. And I take the square root, and I get 17. Okay, so now I know that this height on the outside is 17, and I need that height and that base to find the surface triangle that's on the outside. So I'm going to have 4 triangles, one on each side all the way around, times the area of one of them, which would be 1/2 the base, times the new height I found, which is 17. Okay. We can put 17 in parentheses too. So 16 squared is 256. And then when I work this out, I have 4 times 1/2 is 2 times 16 is 32 times 17, and I get 544. All right, and this is all centimeters squared. So my surface area is going to be the total of the base plus the 4 triangles, and I get 800 centimeters squared. Okay? So that's how I do number 1, a square-based pyramid. All right, number 2 gets a little harder because I'm going to have a regular hexagonal pyramid. So find the surface area. I'm just going to write SA of a regular hexagonal pyramid. And here's my picture. I'm going to have, let's see, the triangle is in front, and I have 2 sides going up like that, and there's the other 2, and then it goes behind, right, like this, and these sides come down over here. And what they give us in the picture, and let's see, we have 10 here. And okay, now the way they draw it is they give us some information about the triangle on the bottom of my pentagon there. So they tell us that this apothem here is 5 squareds of 3, okay? And then we also know that they give us the height here on the outside, and that is 14. So if you look in the picture in the book, it's there. I'll just draw the base. real quickly, and it looks like this. So this is the base. Sorry, it's not that pretty. This is 10, and this is 5 square roots of 3. Okay, so that's the information that they give us, and we want to find the surface area. So for surface area, I'm going to have 1 hexagon, the base, this is my plan, plus 6 triangles all the way around. So I have to find the area of the base and then the area of the triangles. So for my 1 hexagon, I'm going to use my formula, 1/2 ANS. So all that stuff we learned in chapter 11, those were 2D figures, right? The pentagon, the hexagon, even triangles and parallelograms, okay? Now we're using them on 3D. So all of that still comes into play. So the apothem is going to be this 5 square roots of 3. And the number of sides I have is 6. And the side length is 10. So they gave us all that information. That's so nice. All right, so the 2 is going to go on the bottom there. What's this? I don't know. All right. And I have 5 times 6 times 10 is 300 square roots of 3. Okay, when I multiply those all together, and I get 150 square roots of 3. So that is the area of the hexagon, and when I work that out on the calculator, I get 259.8. Now, for 1 triangle, that's going to be area of the base times the height. Now, what information do I have for that? Well, I've got here a side, that's the base, and then on the outside, the height here is 14. So it's 1/2 10 times 14, and that gives me 70. Okay, that's enough information. Now for my surface area, I'm going to have 1 hexagon plus 6 triangles. So I found my hexagon was 259.8, and then I'm going to have 6 triangles. 259.8 plus 420. So the area of the whole thing is 679.8, and this was feet. That is a big pyramid. Actually, not really. I should show you. I actually have climbed inside the pyramids of Egypt. When I was in 8th grade, my father's dream was to see the 7 wonders of the ancient world, and so we went to Egypt in 1979, very long time ago. They were just opening up Egypt, and I got to crawl inside. It was actually quite amazing. Anyway, that's the surface area of our hexagonal pyramid. Okay, one more before we do some OIOs. So, number 3 is a cone. So we're going to find the area of the cone. So a cone, a right cone, which means it has a perpendicular height, is shown in the picture, which we'll draw. What is the surface area? All right, and here's my picture. Now remember, the 5 is over the radius, and this comes down, and this is 6. Okay, so if you actually cut out your the net of the cone shape, it should look like this. So you have a circle like this, and it's attached to a pie shape. Okay, so you have, for a surface area, your plan is going to be 1 circle plus 1 pie shape. So we have to figure that out. Now, the area of the sector has a formula of the pie shape, and that is pi r L, okay? And L, they actually make it into a cursive L. That is this length right here. It's that slanted length that's on the outside, okay? So in my 3D picture here, it would be this length here. That L, that lateral, the length of the lateral face, that's different than the height inside. Do you see that? So the height inside is actually starts in the middle and it goes through the cone. Whereas the lateral side is on the outside and it starts from the edge and it goes in as a slant. Okay, very important that you keep those different because they represent different numbers, all right? So we need to find both things. I need the circle and I need the pie shape. So let's work on the area of the circle. That's pi r squared, which is pi, and the radius was what, 5. So I have 25 pi, and that is 78.5. Okay? So that's my circle. Now I need my pie shape. So that's going to be pi r L. And when I look at the picture, let's go back up to the picture. Okay, well I have my radius and I have the interior height, but I don't actually need that for the formula. What I do need is the lateral L, but I don't have that. So how am I going to get it? Well, again, like a previous example, look here. Look at this triangle here. I can use Pythagorean theorem to find it because what L is over here is also the L on the other side. So this is where I'm going to use the height and the radius. So back here I have to find L, so I'm going to have, let me see, 5 squared plus 6 squared equals L squared. So I have 25 plus 36 equals L squared. 51 equals L squared. Take the square root and I get approximately 7.81. And that makes sense because 7 squared is 49. That should be a little less. And let's see, 51, no, 61. It's 61. This is 61. Yes, that makes sense. Okay. So then, now I have it. So I'm going to do pi times the radius is 5 times 7.81. And what do I get? I get 122.6. So now my surface area is my two shapes together, and that's going to be 78.5 plus 122.6, and I get 201.12. And that is all. That is the answer. All right, I'm going to give you some OIOs. So here you go. Number 1, find the lateral area of the cone. So that means pi r L. And number 2, find the surface area of the cone. So we want to make sure we're doing that right. And here's our cone. And this is 20, this is C, and this is 15. Okay? And then that's number 1 and 2. And number 3 is going to be find the surface area of a regular is very important, pentagonal pyramid. Okay, and let's see, here's our picture. So we're going to have 1, 2, 3, not quite that wide. Oh, this is hard. Okay. And here's the top. And then in here I have my other 2 sides. And one coming down back there. And this is where it gets tricky. Okay. They tell us that this length here in the middle, the height is 4.8 centimeters. And then we have this one here, that would be our apothem, wouldn't it? 5.5 centimeters, and the length of one side is 8. So go ahead and do those 3, and we'll come back in a few minutes and go over them. Go ahead and pause. Okay, I'm going to start going over these and find the lateral surface area. So that's pi RL. And pi RL, that is just the outside. So that's the pi shape, right? So I've got 3.14 times 15, that's the radius, and then I have the lateral surface area. So I guess I have to figure that out. I don't have it, so I have to use, I put C here, you could use L, which is more common. So we have 20 squared plus 15 squared, I'm going to erase this, equals L squared. So 400 plus 225 equals, not add, equals L squared. 625 equals L squared, and L is 25. Okay, so I'm going to put 25 in here. And when I work it all out, I get 1177.5. So again, depending on how you round things, if you had 1178 or 1175.5, if I can see your work and what you did, then I will count it correct if there's no directions about how to round things. All right, so now to find the surface area, I need the circle plus the pi shape. So I have the circle, which is pi r squared. So that's 3.14 times 15 squared. And if I work that out, I get 706.5. Okay, so then I have 706.5 plus 1177.5, and my surface area works out to be 1884, and I think it was feet squared. So this was 15 feet. Okay, so that's my answer, but I need to show all of my work. All right, find the surface area. So the surface area here is going to be 1 pentagon plus 5 triangles, because it's got 5 sides, and I've got triangles on each side. So to find the pentagon, I need my formula, 1/2 apothem and number of sides times the sides. So I've got 1/2, and they gave me the apothem. That was nice, didn't have to do that. How many sides do I have? 5, and then each one is 8. Okay, so when I multiply that, let me check my work really quickly. So that is 20 times 5.5, and I get 110, right? Okay, there we go. So that's the first part. Now each triangle, I need the base times the height. Well, let's see here. Sometimes they have extra information, very often they don't. So let's see what I have here. I've got this here, and I've got this here. But the area that I need, the surface area, I need this triangle on the outside. And I don't have a height, so I can draw one in right here. And then what do I have here inside there? Do you see that? I have that right triangle. So I'm going to pull that out from the inside and figure it out. So I have 4.8 here, and I have 5.5. And I want to find my height. I need this height on the outside. Be very careful. Don't use the height that is inside. Remember, we're looking for surface area. I can use the 4.8 to find the height on the outside, but it is the height on the inside. I hope rewind that if you need to. So important. You don't want to throw off your whole answer by having the wrong height there. So I need to use the Pythagorean theorem. And I get 23.04. This is why we do OIOs, because I bet many of you just use that 4.8 and you have to be careful. It's a good exercise in working it out. So you go, oh, okay, I get it. Take the square root, and h is 7.3. Okay, so now when I go up here, I now know that this on the outside is 7.3. So one triangle is going to be 1/2. The base is 8 times 7.3. And when I work that out, I get 29.2. That's one triangle. So let's go back to my formula. Let's see, my one pentagon was 110, and my 5 triangles, whoops, so I'm going to have 5 times 29.2, and when I multiply that, I get 146. So when I add them all together, I get 256, and that is it, centimeters squared. Okay, I will send home the videos and the homework, and I hope you have a great Monday. Bye now.